evening, everybody. I hope you can all hear me. Welcome to this webinar presented by the IET's Anglian Coastal Local Network. We represent members in Norfolk and Suffolk. Please welcome also to the folks from other parts of the UK and indeed globally. I'm delighted to welcome you all, especially given the competition tonight, a football match apparently between England and Denmark. I'm Ian Buxton. I'm treasurer of the Anglian Coastal IET Local Network and will be your host this evening. Kevin Foster, who normally chairs these, is away this week. So without further ado, I'm delighted to introduce our speaker, David Smith. David is a trustee and director of the People's Mosquito, which is a project to build the iconic W2 RAF fighter bomber, the Mosquito, from its engineering drawings. David has many years' experience in the aviation sector, working in the commercial and business management roles on virtually all the new Airbus development programs. And although he holds a law honours degree, he tells me at heart he's a frustrated engineer and is interested in anything with an engine, especially aircraft and motorcycles. So I think it's time, David, to hand over to you.
Well, good evening, everyone. Thank you for the introduction, Ian, and thank you, George, for helping to manage this. I won't say any more about myself. I worked for Airbus for far too many years. I joined the Department for Transport, and when I retired, I realised that I was missing the buzz of being involved with aircraft. So I started volunteering with the People's Mosquito. And a couple of years later, I'm a trustee and a director, which fills my retirement hours. I'm not an engineer. I'm not a historian. So any mistakes in what I'm about to take you through are mine, I'm afraid, and I apologise in advance if there are any. You should all now be able to see the opening slide of my presentation, which is entitled Returning a UK-built Mosquito to Our Skies. I just wanted to also thank Tim. Tim is one of our supporters who actually arranged for this talk to take place. So thank you, Tim. We do appreciate it. I hope I don't let anybody down. I hope you're going to find this interesting and informative. It's such a broad subject. We have to sacrifice depth for brevity, I'm afraid. But if there's any particular aspects you want to get into more depth, I'm quite happy to find someone who can take you into the real technical detail on another talk. So let's look at what we'll be going through. Introduction and thanks, we've just done that. I'll be talking a little bit about the birth of the de Havilland 98 Mosquito aircraft. I'll be focusing, mindful of this audience, on how it was made and the materials involved. I'll be doing a little bit on engines, not a lot. I did this talk to the Rolls-Royce Heritage Trust and we spent a long time talking about engines. I'll then tell you a bit about our charity, how we were formed, and then I'll close by taking you through where we are on the project and the progress to date. And as George and Ian said earlier, questions at the end. What I won't be doing is going through all the different marks and variants of the Mosquito. We could fill several evenings talking about those. I won't be talking about all the operations either. Again, that could be the subject of an entire evening's talk. So let's start. Let's start by reminding ourselves of the aircraft we're talking about. This is one of the very few that are airworthy in the world. There are 4 over in the States. Most recently, they've been restored by a group in New Zealand, and their workmanship is incredible. And this is a fighter bomber, a Mark 26 fighter bomber that's flying over there. And I don't think you have to be an aviation enthusiast to recognize that this is such a beautiful, elegant, wonderful aeroplane. It's just wonderful. We haven't had one flying in the UK or in Europe since 1996, when there was a tragic loss of tail number RR299 in an air show about 25 years ago. Now that that was quite poignant for me, because working at Airbus at the time, the aircraft was operating out of the Broughton airfield, which is where the wing manufacturer for Airbus is based. And I was shown around the aircraft a few months before its tragic incident by one of the guys who lost his life in that. So that really is something that's motivated me to try and get one of these flying in the UK again. Vital statistics, and it varies according to the mark and the type and the engine type, but its maximum takeoff weight is about 11,340 kilos. It's about 13.5 meters long. It has a 16.5 meter wingspan. Top speed around 415 miles an hour, which at the time it was the fastest aircraft around before the jets started to come in. Range was about 1,100 nautical miles, and it could fly to a ceiling, a sort of maximum altitude of around about 37,000 feet. There are 35-ish variants of the basic aircraft. My favorite is the Mark 18 Tetsi that had an artillery piece mounted in its nose. Tetsi was a nickname for it, and it was used for submarine hunting. Last operational sortie was in December 1953, and it was used towing target tugs until 1963. And sadly, some of the last airworthy airframes in the UK were actually destroyed during the filming of a film that we don't mention. And I'm sure you can guess which one that is. Anyway, don't take my word for it. When the charity started, our patron was a gentleman called Eric Winkle Brown, who was a famous test pilot, and he's in the Guinness Book of World Records as having flown the most different aircraft types. Now, he sadly died a few years ago, but before he did, he recorded quite a few interviews for us. And what I'm about to show you is a 2-minute clip of his thoughts of the Mosquito. Let's see if this works.
If you look at the British aircraft industry as a whole during the war years, there were about 5 top manufacturers. De Havilland's certainly one of them. I had a very high regard for them, and the test team too. As you look through the air shows around the world, there's a certain dearth of mosquitoes. Here's one of our top airplanes, and not many around the world. Any attempt to restore, particularly to flying status, a Mosquito would be a really gift to our heritage. We need something like this to remind the British public how it was and what were the tools that really saved the day for us. And when you talk about that, the Mosquito's in there, believe you me. First time I saw it, I realized it had all the looks of a potential winner. For its time, it was incredibly beautifully streamlined. It just oozed power, really. Naturally, when you have looks like a good one, you expect it'll fly similarly, but it exceeded all expectations. And was one of Britain's 3 great aircraft in World War II. We had, to my mind, 3 really greats: the Spitfire, inevitably, the Mosquito and the Lancaster. And they all had a huge part to play. Maybe the Mosquito more than most, because it was very versatile. Fighter, night fighter, bomber, did the lot. And when it was flown as a pathfinder aircraft, it really showed its worth.
So there is the thoughts of Eric Winkle Brown. I do recommend the book about him called Wings on My Sleeve. And he actually made the first carrier landing of a Mosquito. But that book is a very good read. Right, let's look at how the mosquito was born. Now, if you do any research, you'll come across this quotation, which comes from a letter that Sir Geoffrey de Havilland sent to the Air Ministry. Now, Geoffrey de Havilland had his aircraft company, which he started in about 1920, I think it was, responsible for many famous and good aircraft, such as the Tiger Moth, Dragon Rapide, Comet Racer, more of which later. And he was getting into large wooden airframe manufacture with the Albatross commercial aircraft. So he was badgering the Air Ministry to try and get work in making a twin-engine bomber that was depending on speed as its defence. And yes, if you look at this, Geoffrey de Havilland's company was ideally suited to develop this type of aircraft, but the concept of a fast twin-engine bomber first surfaced in May 1937 in a memo from a Handley Page employee that was sent to the Air Ministry, a certain gentleman called G.R. Falkirk, and that was about a 30-page memo. And this did the rounds in the ministry, and eventually a consideration paper of this concept came back out from the Air Ministry, a copy of which is available in Kew if you want to go and read it. But the concept was not popular. The conventional wisdom was bombers needed to be heavily armed and they flew in big formations to actually defend themselves. So a nimble aircraft outrunning its enemy was not a popular concept. But certainly Geoffrey de Havilland was pushing to get production of this type of aircraft. So looking at the timeline, 1934, his Comet Racer, that's the little red aircraft you see there, won the England to Australia air race, and I think they won a prize of something like £10,000, so forgive me. Then the Albatross, de Havilland design number 91, in case you're wondering what the DH stands for, which was the wooden airliner. I think 3 of those were made, but you can look at the date. It was probably the wrong time to be bringing a commercial aircraft to the market. October 1938, de Havilland was lobbying the Air Ministry and trying to get more interest in the unarmed bomber concept. And he's alleged to have said in frustration after another frustrating meeting to one of his colleagues, "We'll do it anyway." Now, if you're interested in that period, there's a book called The Wooden Wonder by a gentleman called Edward Bishop that was written in the 1950s. And it does go into all the characters and the intrigue and some of the environment that of the time. A very good read. Anyway, eventually, November 1939, a draft operational requirement came back out from the Air Ministry, and it included this really important phrase: wooden or composite construction employing materials, classes of labour, not available at great extent on standard aircraft for the RAF. If you think about it, the focus was on stressed metallic single engine fighter aircraft at that time. But that was a very important requirement because that played right into Sir Geoffrey's hands. So if we then go on with the timeline and we introduce the second gentleman that we have to be thankful for, the first contract was placed with de Havilland in March 1940. And then specification eventually evolved, starting to sort of see the prospect of its versatility into long-range fighters. And a little pub quiz fact here, it's not until June 1940 de Havilland design number 98 was renamed the Mosquito. And I believe there's been something in the papers recently about Bomber Harris not liking the name Mosquito. Well, I've not read up on that, so I can't really comment. But what I do know from what I've read is that during that period, there were attempts to cancel the project. And we've got to be thankful for Air Chief Marshal Sir Wilfred Freeman, And here's another book I recommend, and this is absolutely fascinating. It's about what he did in influencing some of the development of aircraft technology during that period. It was the project was known as Freeman's Folly because he was really the only defender of the concept in the halls of the Air Ministry. Anyway, first flight, November 1940, went to Boscombe to do trials and armament proving, and then first operational sortie, September 1941. Now just pause for a minute and look at that timeline and have a little think. Now, I don't know how many of you have been involved with aviation, but I can tell you as an ex-Airbus man, if some of our projects had gone from concept through to first flight in that sort of speed, I would have been delighted. And I think that's got to recognise the sort of the hard work of the team that Geoffrey de Havilland put in place near Hatfield there. And the other interesting thing is, despite all the development that went on with the aircraft, the airframe was essentially the same airframe from the prototype through to the last marks. So those two gentlemen are who we have to thank. Now, this is the prototype. These are pictures taken at the time, and I'd just like to acknowledge that I think they're BAE Systems ownership. They are available on the internet, so but I'd like to acknowledge their ownership of them. And this is at Salisbury Hall, which is where the first 3 Mosquitoes were built, and that is the prototype. And what amuses me is the crude camouflage, the sacking draped over the airframe to disguise its sort of shape for anyone who might have been snooping from above. Now, after the first 3, the production moved to Hatfield, the de Havilland main factory at Hatfield. This is the prototype today. This is at the de Havilland Museum at Salisbury Hall. It's the very same aircraft we saw in the earlier pictures. Just having a sip of water, excuse me. And what I would like to say is we absolutely love what the de Havilland Museum are doing. We're not connected with them in any way. We're not trying to compete with them, but our thrust of our charity is to get an aircraft flying, not open another museum. They have a superb collection there at Salisbury Hall. I'd urge you to go and have a look there. After the prototype, there were another 7,780 built during the period from 1941 to 1950. And just as a point of comparison, there were 20,351 Spitfires, 14,487 Hurricanes, and finally 7,377 Lancasters built. Now, it seems today that there's a new Spitfire coming out of restoration every month, and there are 2 airworthy Lancasters in the world, so you can see why we're so keen on not letting the Mosquito get forgotten. So there's the prototype. Go and have a look at her. So where was it made? Now, de Havilland had their main factory at Hatfield, so obviously of all the aircraft made, a large proportion were at Hatfield. But it's also made in Canada and Australia, and the picture on the left is from the Canadian production line. The picture on the right is from the Hatfield production line. And you can see the breakdown there of the other production sites, including, interestingly, Standard Motors at Canley, made over 1,000 of them. And there were 96 built at the Broughton site near Chester, which is now the Airbus wing site. And the last one, last Mosquito ever built, was built there in November 1950. Now, to answer a question I'm sure someone is wanting to ask us is, how long is it going to take for our project to get an aircraft flying? Well, the answer is, if we had all the money in the bank, a realistic target would be have one flying on the 75th anniversary of the last one being made, i.e. 2025. Now, that's what, we're not sort of saying that's what we will do because it's funding dependent, but that is our target, is to have one flying to celebrate the last one being made 75 years previously in November 1950. Now, supporting those production lines, and this is where the sort of the statement about wood was important. There were parts being made in sheds, there would be parts being made by furniture manufacturers. So it was using a supply chain of labour that wasn't overwhelmed by other important war work. So it met its requirements in doing that. And we very often have people come to us and say, oh, my auntie used to make some of these. She worked at the Parker Knoll factory. It's amazing. And we love to hear from people who have got a connection with the mosquito in whatever way, shape or form. And yeah, they estimate there was something like 12,000 skilled workers involved when production was at its peak. So that's where it was made. Let's have a look at how it was made. Now, we'll start with the wing. Now, this is where I'm afraid I read from a slightly prepared script. Now, the words I'm about to read out are from an Aeroplane magazine article that was published at the time in the 1940s after a visit to the Hatfield factory. So let's start with the wing. And what you can see on the right-hand side is the sort of the wing structure coming together. Top left, you've got the final wing assembly with the engines attached, and bottom left, you've got the false trailing edge being made in conventional metals by those ladies on the trestles there. So this is what the Aeroplane magazine said. The wings are built up in a single section from tip to tip. Center portion carries the radiator and engine mountings. You can see those in the photo there. The fuselage drops on top of the center section and it is secured by 4 massive pickup points. It's got 2 box spars with ply webs and laminated spruce flanges. The front spar has 3 laminations at the top and 11 at the bottom. The rear spar has 3 laminations at the top and 9 at the bottom. The skin passes right across the top and bottom of the spars and is double thickness on top with spanwise spruce stringers sandwiched between 2 layers of ply. I always have to be very careful when I read that out. A false leading edge was attached to the front spar of conventional built-up construction, and that's what you can see in the small picture on the left. And the whole wing is screwed, glued and pinned and covered with fabric on top of the ply. So that is the wing construction. Let's now look at the fuselage. Now this gives you an idea of the challenge we've got, because what we're looking at here in the bottom right of the screen is a mold which the fuselage shell is formed across. Now the straps are actually pulling the fuselage material down over the mold to get the shape, and you can just see the front fuselage section in the top left in the photo on the top left, and you can see how it comes off the mold almost like a complete eggshell. Again, let's go back to the Aeroplane magazine narrative about the fuselage. Built in 2 halves on 2 half jigs or molds. Split along the top and bottom from nose to tail. Construction is very similar to the Albatross aircraft that we talked about earlier. Now this is important. It's a sandwich skin made out of an outer layer of ply, a center of balsa wood and an inner skin of plywood. So it's a sandwich construction, a balsa sandwich. Points where the bulkheads are attached, the balsa core is omitted and a spruce ring is substituted. Now get this, the skin varies in thickness from 1.5 to 3 millimeters. And the fuselage has got 7 bulkheads nose to tail, each built of 2 plywood skins kept apart by spruce blocks. And where the skin is most stressed, the plywood is wrapped diagonally. Now you can see that better in these photos. You can see the 2 fuselage halves, and you can see the orientation of the plywood in the top left there, where the lady's standing. You can see the bulkheads running down through the fuselage. And what you're also looking at here is how they assembled the fuselage equipment, oxygen bottles and what have you, inside the two halves before it came together as a single fuselage assembly. So that is how the airframe, the wings and the fuselage sort of were made. Now what we're looking at here is a complete fuselage assembly joined up with the canopy attached, and the little drawing at the bottom there, you can see how that would come down onto the single wing with the engines, just like an airfix kit, to complete the aircraft. Now that's a photo from one of the many subcontractors who were working on the project at the time. And you can see how it is literally just like an airfix kit. Now, later this autumn, there is a program on Hornby, on the company, the model company, and we have got a few minutes in that talking about our project because of the comparison to model making with the actual aircraft construction. Now, this is a cutaway of the airframe, and you can see the sheer amount of wood in the airframe, which is why it was called the Wooden Wonder. The two engines sticking out the front there are probably, with the undercarriage legs, the most metal in the aircraft itself. The black sections in the cutaway wing are the fuel tanks, which were sort of rubber tanks inside the wing. And you can see how the spiral winding at the back towards the tail is shown as well. So that gives you an idea of what we are putting together to fly again. And I think apart from the undercarriage and engines, there's only something like 130 kilos of metal components in the airframe. The Wooden Wonder indeed. Now then, the most observant of you may have noticed in the pictures of the wing, the works instruction there, whatever you do, don't spare the glue. Now let me just make sure I've got the right notes for this section, because the glue that was used to put it together is something called Kaysan, and for the those of you who are interested in such things, it was British Standard 4V2 Kaysan glue for aircraft production. You can look it up, and it had to be, the British Standard had to be modified because there was a shortage of walnut test strips to test adhesion of the glue. Anyway, Kaysan is a glue, and it was used in the Middle Ages to bind thin panels onto thicker plates. An artist used to paint on them. It was used extensively in woodworking, and the picture on the left there of the building is actually Stockholm, where is it? Stockholm Central Station in Sweden, built between 1867 and 1871. And it used Kaysan glue for huge laminated arches in there. So if you ever go to Stockholm, you can air your knowledge about the construction of that building. Is technically, it's a salt of the element calcium, which incidentally is a metal. It's an alkaline earth metal, so my engineering friends tell me. But it's found in about 80% of the proteins in milk. Now that leads me on to the other photo, and that is some cheese. Now, in his book, The Mosquito, Bill Sweetman talks about some of the issues with Kaysan glue, and he says, and I quote, "Time expired camembert, which rotten Kaysan glue sometimes resembles, is not a good structural material." So that's why I show the picture of Stockholm and the wing, because we can talk about the glue against it. Now, I do recommend this book. It's got some tremendous artwork in it, which, if you can get hold of it. So there we are, there's the glue. Now, how good is wood? Now, we've got hold of a document, which you can see on the screen there, which was a report of a commission of American forestry and aeronautical engineers who visited the UK in 1943 to look at what the Brits were doing with wooden aircraft construction. Now, it's a fascinating document. I'm not an engineer, so I find some of it is well over my head. And I note that IZOD is not recommended as an inspection test. Now, this document tells you why, but it's absolutely fascinating. It was classified at the time, and we only have a copy for research purposes, but it's incredibly helpful in what we're trying to do. Now, just to skip to some of the conclusions of that document, it does make a comparison between wood and metal aircraft, and being written by Americans, it spells airplanes wrong. But wood requires more maintenance than metal airplanes, but is more easily repaired after crashes. Damage and deterioration is more easily detected in wooden aircraft, and I think you can spot the damage in the wing of the aircraft in the photo to the right of that statement. All the repair is done by hand methods. For example, bullet holes through the skins are repaired by scarfing in plywood patches. Now, interestingly, when we go to air shows, we have people come onto the stand, and we had someone come on with one of their relatives' notebooks and a set of woodworking tools. He'd been looking after mosquitoes out in the field, and the picture on the right there is an extract from this notebook, and the tools. We talk about educating, and remember, these are so important, that these techniques, we're capturing the knowledge there and making sure it's preserved for future generations. But the notebook, again, it's a fascinating document. You can flick through it. It's all his notes from his training and sort of things he'd done in the field. But the main enemy of a wooden airframe is moisture. And you've got to inspect the drain holes every day. Now, that obviously puts a maintenance cost up, makes it quite high, but to offset that, the repair cost is lower. Now, I'm sure you materials engineers would be familiar with this book. It's called The New Science of Strong Materials by J.E. Gordon. And there's actually a section in there about wooden, and he talks about the mosquito, about wooden airframes, and he does talk in here about some of the issues with keeping the drain holes clear and making sure the wood doesn't splinter and block the drain holes. A good read. As a non-engineer, I found it very approachable. I recommend that one as well. So let's talk a little bit about engines. Now, we need some. This is a head-on shot again of one of the airworthy aircraft in the States. It's a fighter bomber Mark 26, very similar to the fighter bomber Mark 6 that we're doing. Now, what a lot of people don't realize is both engines rotated in the same direction. Now, while you think about that, think also about how close the yellow tips of the propellers are to the fuselage and to the cockpit where the crew are. You've only got about a few millimeters of plywood between the edge of the rotating propeller and the crew there. Now you can see the radiator inlets on the inboard of the engine, and you can see the undercarriage legs there. And interestingly, they're not hydraulic; they're filled with rubber blocks. So it's quite basic technology. But it's still a beautiful aeroplane. Now, the two engines rotating in the same direction was because of the volume of Merlins being produced. They're all the same. But there is an issue with takeoff, because you have to get to what's called the blue line, or the safety speed, with both engines. If you lose one engine on takeoff before you get to that speed, and it can be quite a beast to handle, I'm told, your only option is a controlled crash, which is why when we operate our aircraft, we're looking for a site that's got a good runoff area from the runway in the hopefully unlikely and never to happen event of losing an engine on takeoff. This is what we want. So if you've got any of these in your shed, please get in touch. We're looking for 3, because we want a spare, Rolls-Royce Mark 25 or Mark 225 Merlin engines. The 225 denotes it was built by Packard in the States under license, and because their machine tools tended to be newer, the story is that they could hold closer tolerances than UK produced Merlins. The Merlin engine, we could spend an evening talking about it, something like 27 litres V12. Each cylinder has a cubic capacity greater than the cubic capacity of the engine in my family car. So it's a beast of an engine, 2-speed, 2-stage supercharger. We reckon when we're flying at air shows, if we do 100 hours a season, it's going to cost us about 150,000 just to keep the engines overhauled. We're still looking for some technical data on reconditioning and salvage, and we're looking for a set of tools as well. So as I say, if you've got any tucked away in your garage, please do keep in touch. Now, before we move off from engines, when we do these talks, we try to make them interesting to the group that have invited us. Now, for Rolls-Royce, I had an awful lot of information on engines, engine development to present, but as this talk was arranged through the East Anglia branch of IET, I naively asked a sort of an expert who works as part of TPM, was there much mosquito operation in the Norfolk area? And he sent me this list. Now, again, we could construct another talk with what we have access to with the records, because we've got into all the operational records out of Kew, out of the National Archive. And what we're saying is, if Lincolnshire called itself Bomber County, Norfolk can quite rightly call itself Mosquito County, with the amount of operations, squadrons and activity in the area. Now, we've also got this information for Suffolk, but it would just make the slide far too difficult to read. And I believe your group also had a talk about the radar, the oboe, including oboe. And here's a picture of a mosquito operating with the oboe radar and the Winterton station at Norfolk. Now, we've also got a film clip, a period film clip of a brief intake in place at that station, which, again, happy to share in another talk if people want to get into that. So we're rattling through this. I'm trying to keep it sort of interesting. Let's now talk about our charity. How did it start? Now, it was born out of social media. John Lilly, our chairman, inspired by the work the New Zealanders were doing in restoring the mosquitoes, and by the work the Vulcan to the Sky Trust were doing in getting 558, the Vulcan that displayed recently, back to being airworthy. And he just put out a tweet saying, wouldn't it be a good idea if we got a mosquito in the UK again? Now, he was working in Shanghai at the time, and from that one tweet, a group came together of like-minded individuals. That group slowly formed a little club. That group emerged and became a registered charity. And if you're into social media, we've got something like we've got Twitter, Instagram, we've got Facebook. But we've got something like 50,000 people who actively look at our social media postings. We've got a little club, which you pay some money to join, and we've got over 13,000 members. That's probably gone up since I did this. And if you do nothing else, go into our website there. There's the website address at the bottom of the page, and you can find out more about us. And if you want to get in touch by email, info@peoplesmosquito.org.uk is an email address that will find us. So it started from an idea, and it's now a charity. We've now raised a lot of money towards our project, not enough, and we've gone from strength to strength. And I'll just take you through firstly, the team. Well, our new patron since Winkle Brown sadly died is a gentleman called Arthur Williams. You may recognise him because he has done some programmes on Channel 4 about where he flies around in his little Piper Cub. He was an ex-Marine who was disabled, taught himself to fly. Fascinating chap, lovely story. And both he and I were born in Cheltenham, we discovered. But Arthur has done something no one else in the team has done. He took the controls of one of the airworthy mosquitoes in a program he did for Channel 4 called The Plane That Saved Great Britain. So he is full of enthusiasm and very supportive of what we're doing. John, who put out the initial tweet, is our leader. Our Director of Engineering and Airframe Compliance, and such a knowledgeable man. I've not met anyone who is as knowledgeable as Ross on the mosquito and heritage aviation. He's relocating out of the States to the UK a little bit later this year. Our Director of Flight Operations is a gentleman called Wing Commander Bill Ramsey. He's retired. You may recognise his name. He was part of the crew that flew the Vulcan 558 in its last display years. He also happened to fly with the Red Arrows, and he also flew with the Battle of Britain Memorial flight. So although he's retired from RAF, he is a huge supporter, and he's charged with making sure that when we operate the aircraft, it's safe. And he is getting around talking to surviving veterans to get the commentary from behind the published pilot's notes. Right, I've just been reminded I'm talking for too long. Steve runs his own IT company. Alan has just recently retired from the oil business, and I'm head of begging at the bottom there, and you know all about me. So what does the group need? It needs an aeroplane. So we've acquired what's called the mortal remains of an aircraft tail number RL249 that crashed at Crottleshaw. Now, it always brings the question, are we doing a restoration or are we doing a replica? Well, the fact is we're remanufacturing. You can see from the remains there, it's not a restoration. We are remanufacturing. Now, the holy grail for us is to get the permit to fly from the CAA so we can operate in the UK. So we need to remanufacture essentially a new airframe. Now, when the project started, the only people doing this sort of work were over in New Zealand, and this is some photos of some wing ribs a company called Aerowood did for us when they were doing a batch for one of the aircraft we've seen now in the States. And if you come to see us at an air show, we got some of the test samples. You'll be amazed how strong and light the wing ribs are. Anyway, now we come to the pivotal moment in our project. John, our chairman, took a phone call from a chap at Airbus in Broughton. Now, if you remember, I said that the last flying mosquito in the UK was based at Broughton, and this chap said, we're knocking down a hangar. We've come across a filing cabinet full of drawings. Are you interested in them? Otherwise, we're going to put them in the skip. Within 2 hours, John was across there, and he drove away with literally black bin liners full of microfiche drawings. And they are not a complete set, but essentially virtually every drawing you need to make a mosquito in microfiche. Now, we've paid money, we've had them digitized, we've done some CAD work, but we are now able, this made us able now to move away from the New Zealand based manufacturing and start to look at doing it in the UK. Now, here's an example of the drawing. I won't go into too much detail. You can see the grain orientation. You can see the spec of the spruce it's grade B. There are actually 3 different grades of spruce if you want to get into it. And what amuses us is this one was drawn on Boxing Day 1940, so there's no rest for the de Havilland workforce. But being able to do this in the UK, we engaged with a company called Retrotech. Now, Retrotech is run by Guy and Janice Black. Guy started his career working for Westlake Engines and then started his own engineering company, Lynx Engineering, did a lot of work with racing Jaguars, and then taught himself to fly. And then as you do, he bought himself a Spitfire, and he now operates something called the Historic Aircraft Collection that has got a Spitfire, a Hawker Fury, I've forgotten the others, but he's got 3 or 4 aircraft that he has restored based in Duxford that fly. And his last project was a de Havilland 9 wooden First World War bomber that you see in the picture there. He's written a book about it. Very good book, do recommend it. And he found that airframe in a viceroy's shed in India. But the key point is he knows his stuff, and his company carries the requisite approvals from the Civil Aviation Authority to do this work. Now, Aerowood, one of the subcontractors in New Zealand, got into financial difficulty, and we were able to get hold of the wing and a lot of the other jigs needed to make the airframe. And those came in through Southampton, and they're now safely at Guy's factory in Sussex, where they'll be used when we get to that point of the build. We had a contact from a wood supplier who'd been supplying the New Zealanders, and they've got basically a cut list for the aircraft. They do all the testing to the right specifications. If you're interested, you can find them on YouTube, and they rebuilt the de Havilland brittleness testing machine, and they do all the humidity, weight, density of all the piece. And they said, we can send you a kit, but you know, ugly subject to money, we will need some money from you. Now this organization actually sources its spruce from the same plantation in Canada that supplied the Canadian production during the war years. And guess what? We've got some wood from them, which again is now in Guy's temperature controlled factory down in Sussex. So where are we at the moment? Well, the work is proceeding at Guy's company Retrotech. You've got a picture there of his approval certificate, and that's his accreditation. Now, the fuselage molds were the major part of the manufacturing tooling that we were missing. There is a set in New Zealand, but they belong to a different organization, so we've had to build our own. And they are just about coming up to completion. We launched what we called Operation Jericho as a fundraising campaign to pay for the molds, and that's just finished, and that ran through last year. And the molds are there or thereabouts now, ready for use. We're just getting the bulkheads made for the fuselage now, because that helps get the final profile of the mold correct. Interestingly, in the drawings we've got, we found the datum point for where the bulkheads would be positioned. Some of the drawings had them from an end, some from a center line, so that this, the drawings weren't completely without flaws. Now, because we want the certificate, the permit to fly, we've got to do so much work to satisfy the civil aviation regulations, and there's a lot of invisible work that goes on that needs funding. Now, once we got the bulkheads finished, we can then crack on and get the complete fuselage shells that we saw in the earlier photographs molded across our molds. These pictures are quite old now. The molds are in a much more finished state than these pictures show. Now, rather than mahogany, which some of the original molds use, we use a wood called joltong, which is more sustainable, still a hardwood used by pattern makers. You can see a great big steel frame to take the load as you strap the fuselage material down over the mold. Here are some bulkheads, and that gentleman in the left in the blue overall is a gentleman called Arvi. He's Lithuanian, and he built wooden gliders in Eastern Europe before he came to join Guy. And this is bulkhead number 3, I think, and you can see how we're cracking on to get the fuselage bulkheads finished. While all this is happening, we are slowly acquiring other parts. Here's some pictures. We got a spinner, we got a glycol tank. Retrotech are making some control panels for us. There's exhaust stubs there. Lovely find was an original control column. We've recently picked up a throttle quadrant in the picture on the left there, and that is actually part of the rudder pedal assembly on the right, and you can see its applicable drawing beneath it. Now, I've rattled through that, but the key points to remember are, as a charity, of every pound we raise, 88 pence is going to the aircraft build. None of us take any salary or any money out of the charity. We're all doing this out of a sheer passion to get the aircraft flying again. We've got, with the molds now, all the major manufacturing tooling. We've got a drawing set, which was supplemented by some drawings we got from the Smithsonian Institute in Washington. We've got an approved and trusted contractor to do this work. And as I say, if we had all the money in the bank today, we're probably about 4 years away from completion. Now, I've rattled through that quite quickly. Thank you, George, for telling me about the time. We're now into questions and answers, and please, our latest campaign is called Operation Crossbow to help fund the fuselage build itself. And if you want to look up more about Retrotech ourselves, or get in touch by email, the websites and the email addresses there. That's it. I hope you found it interesting. I hope that my passion came across, and I hope you do find out more about us.
Thank you, David. That was very interesting, and I think your passion shone through. So thank you for doing that. And we'd just like to move into Q&A if we could. I can see that there's loads of questions, and I'm sure that we probably won't have time to get through all of them, but I'd like to hand over to George, if we could, to manage this next section and see how many we can get through. So with that, George.
So let's move on to the open questions. One from Kevin Silver. To what extent do you expect to be able to match material to the original production? And from a safety point of view, has this been challenging from a certification of the planning process?
Okay, let me answer that in 3 ways. Firstly, the wood material, we have the wooden spec. So through Touchwood, we are able to source the correct wood, spruce, balsa, etc., etc., and get all the testing done to prove to the aviation authorities that it's good to fly. The glue is one of the major changes we're making. We're moving away from K-San glue to a modern epoxy resin. Please don't ask me the spec, I can't remember it. But that is an approved modification already through the CAA. So we're able just to take an approved new glue to replace the K-San. Now, finally, the parts, a lot of the parts like the engines, a glycol tank, the beauty of working with Guy is he's got the right approvals to do overhaul work on those parts to prove, the glycol tank, for example, he can do a pressure test, a leak test on it. So we're able to prove where we are using original components after Guy's been over them, that they will be safe. Now, with the drawing set, and interestingly, we're getting a new casting made for the tail wheel. With the drawing set, we can make anything, if that makes sense. We've got the data to be able to go out and get new castings made, fasteners, what have you.
Thank you for that one. A quick question from Mohammed Adamu, who has PhD. How were the mosquitoes recycled?
How were they recycled? I don't know. I should imagine a lot of them were just simply scrapped, and in the days when they went out of service, they would have been put in landfill. There wouldn't have been the same focus as there is today on sustainability and recycling the airframes. Interesting little story. We had a guy bring a fire guard onto the stand at an air show recently, where someone had cut a hole in a mosquito fuselage many years ago to put a camera in, and they'd kept the section of the fuselage and was using it as a fire guard in his house. But yeah, I don't know is the answer. I'm guessing that they went to landfill or were burnt, the original ones.
Quick question from Tim Bushell. Where was the last mosquito made?
Broughton. at the Airbus factory near Chester. It was in de Havilland's hands at the time in 1950.
Okay, from David George, which UK bases did the mosquito fly from?
Whew, well, I showed you the slide with the ones in Norfolk. There is a huge list. I do not know them off the top of my head, but if you are really interested, I can send us an email in, and we can get that list for you. They were all over the country.
Okay, looking forward, Phil raises an interesting question. When you make that first flight, do you know where it will be made from and to, and how will people like me find out about it?
Right. Well, as an ex-aviation person, true first flights are very rarely public. There is a first flight and there is a public first flight. So the aircraft, we're looking at either Duxford or East Midlands Airport, where Rolls-Royce have got a hangar as being our base. It's most likely the first flight will be done at Duxford, because that's where Guy's got his aircraft and there's facilities there. And don't worry, we will make a splash when we go public. And we've actually got a scheme. If you want to pay us some money, sorry about money, you can get a ticket to the public first flight. Go onto our website and you can have a look.
Thank you. Where is the registration being done, and is it possible to visit to see the progress?
Yeah, we have already reserved a registration number on the CAA register for our airframe. And yes, the work is being done at the moment in Guy Black's factory down in Sussex. And we've got an open weekend this weekend if anyone wants to buy a ticket to come and have a look. And when the aircraft is built, it'll then move to where it'll be dismantled and moved to where it'll fly from. But yes, you can come and visit on open weekends to see the work in progress. And again, through our website, you can get details of that.
From Andrew's iPad, how many Polish Air Force squadrons were equipped with the Mosquito during World War II?
I don't know. I'm the wrong person to ask that sort of statistic. Again, either send me an email or someone can take your contact details. I will find out for you. I don't know. That isn't my area of expertise, but if Ross was on here, he would probably tell you without even drawing breath. He would just know. So I can't answer this tonight, but I will, if you're interested, get you an answer.
Okay, and from Tim Wollstonecroft, was the structure very tolerant of damage? And he would assume so, given the nature of wood.
Yes. Again, the document I was waving around earlier did do some sort of comparisons on sort of bullets passing through the airframe, and the conclusions are that the wooden airframe was more tolerant to bullet damage than a comparable metal airframe.
And John Pettit is asking about glue, and I know you've talked about glue fairly extensively.
Yeah.
What glue was used in bonding the wooden parts, and what types of pins were used?
They were
in dinghy building. He used Cascamite wood glue with ringed copper pins.
Right. There were brass pins used, because you don't glue without a screw, as the saying goes. Mosquito used brass pins. We'll be using an epoxy resin. Again, sorry, the detail of the spec is I just don't know it. And that will replace the original Kaysan glue that was used in the original production.
From Steve Morton, asks, why do you think the Mosquito hasn't been restored, preserved as much as other similar vintage aircrafts?
Because it's made of wood.
Quick question. Yeah. Quick answer. From Philip Brown. They
deteriorate.
Yeah. From Philip Brown, have you seen the Mosquito with built-in artillery piece in the Brussels Cinquantenaire Military Museum?
I haven't. It's on my wish list of places to go. I urge all of you to sort of look up Mosquito Tetsi. It's quite amazing. They mounted an artillery piece in the nose of the aircraft, and the mechanism to load the shells was made by a cigarette vending machine manufacturer. But no, I've not been to Belgium. That's on my list.
And Brian notes that he has had the pleasure of seeing the Canadian mosquito that was refurbished in New Zealand, and he saw it fly in Virginia Beach. He says, what kind of wood laminate are you going to use in the restoration?
I don't know. That technical detail is beyond me, I'm afraid. Don't forget, I'm a commercial man, not the engineer. But again, if you want to find out, get in touch, and we can get you an answer from someone who does know.
Technical question from Chris Newell. Are you taking any special steps to address the carburetor problem under negative G, which contributed to the crash 25 years ago?
Yes. In a word, yes. We are very well aware of that, and that's one reason why we're going with the Packard 225. It's a different fuel system, I'm told. Again, if you want more detail, drop me a line and I'll get someone who knows all the ins and outs rather than sort of flounder around guessing tonight. But yes, we are aware of that issue and we are taking steps to not have the same issue.
Okay, I have a question which I think is about the estimate of cost and qualified pilots to get the mosquito to fly again.
Right. Well, cost is, you know, we always expect this one. Our current estimate is that we think it's going to be about £8 million to get the aircraft flying. In aviation money, that's not a lot. It's a fraction of what the guys needed to do what they did with the Vulcan. We are probably about an eighth of the way there now on the fundraising. We have had corporate sponsorship from Airbus and other companies. Not enough. We'd like more, but it's doable. You know, with the thrust we put on, with the merchandise we sell, with the packages, we are getting donations, and we're about 8 million. If anyone wants to help us out. Sorry, there's a second part to that question as well, wasn't there?
I've moved on, I'm afraid. So.
Okay.
Les asks, can we have a bibliography? I guess that relates to the books that you were showing.
Yes, yeah. I'm not sure how I get it to you, but I'll write down all the books I've held up and recommended. And if like you're interested, they are good reads. And
we can put that on the ACN site.
Okay, I'll make a note to send that to you then.
Yeah. I think some answers to questions, so I won't raise these. Is that from Neil R. Regarding moisture being the main enemy, is there any truth to the idea of mosquitoes coming apart from glue failure when deployed to the tropical parts of the Far East theatre?
Right. If you go to this book by Bill Sweetman, it discusses that issue, and yes, there were issues in the tropics, but the findings weren't as straightforward as it was just, you know, the humidity over there. I won't go into it now, but if you want to get into that detail, that's discussed in this particular book.
Okay.
Haven't got that page marked, otherwise I'd find it and read it out.
N. Bukorovic, or Bukorovich, is the Merlin engine the same Merlin engine that were used in the Spitfire?
It's a different mark. We were talking about Mark 25 or Mark 225 versions for the Mosquito. It is essentially the same engine, but a different mark. If that makes sense.
Okay, from Dave Davis, you mentioned the casein glue, and Dave notes the issue with Far East mosquitoes, and that the casein was changed in later builds.
Yeah.
And what glue is used on your build. You mentioned epoxy, but
I can't remember the spec, I'm afraid. There are
okay.
2 approved for aircraft use, and I can never remember the specs. I got them written down somewhere.
Okay, so there's a statement from Steve S. White about water drainage.
Yeah. Keep your drain holes clear.
Yeah. Can Elliot G understand a little bit more about the modern components that you're using to make the plane more reliable and easier to maintain?
Okay, well, we will be having to put some modern instruments in, but essentially, unless there is a pressing need, we will be staying as original as possible. Guy's whole premise is, we're not building a quasi mosquito, we're building an original mosquito with approved safety changes. We're not making as I say, a quasi mosquito. We'll be as original as possible.
Paul Jackson recommends that a chap by the name of Andy Gillard at Sika UK regarding adhesive would be a good contact. So I'll note that one for you. And from N. Bukorovic, will you be using imperial measurements during manufacture, or has everything been converted to metric?
It's interesting. The drawings use imperial measurements, but a lot of them are in decimal. If you remember the piece of structure I showed the drawing of, that's had something like 4.6 inches rather than 4 fraction. So yes, we'll be using imperial, but strangely some of the drawings have the imperial measurements to a decimal place, but not converting it to metric. Now, if anyone knows of a Faro arm, a measuring device, we're looking for one of those to help us get the profile of the fuselage measured. So if you've got one of those tucked away, we're very interested in that.
Sally asks, how did they get the fuselage shape over the molds?
The balsa is sort of held down by the big metal straps over the mold, and then it's just the strap holding it in position while it sets that forms that sort of eggshell type construction. That's a bit crude, but that's how I understand it. You basically bend it over and strap it down.
And Mohammed Adamu asks, what material are you proposing to build the nose of the new mosquitoes with?
The version we're doing will be a fighter bomber Mark VI. I believe it's, again, balsa, apart from the sort of the holes that the armaments stick out through, which is some sort of steel. We will not be using a perspex nose because we're not doing a photo reconnaissance version. We're doing essentially a fighter bomber which will have balsa in the nose. The canopy, the aircrew sit under, is again perspex with armored glass at the front.
Will the finished aircraft have a military registration number?
It will have a civil registration number, but it will be painted with a military colour scheme. That's not unlike a lot of the historic aircraft flying today.
A number of people are thanking you and offering to be counted in.
Excellent. I'm amazed so many people have stayed with this, because I understand the other event has now started.
Jerry Sable is looking as an engineer to volunteer. So what we'll try to do is we'll try to make sure we've got a summary of the QA that you have here.
Yeah, get in touch, because we've had other people step forward, and you have to work under Guy's direction. He's got the signatory authority for the work. So, we're grateful for anyone who is offering to help, but the condition is it's got to be under Guy's supervision and direction, because ultimately he signs off to say this work is good under my CAA approval. But yeah, thank you. Excellent.
An anonymous attendee asks, do you plan to rebuild new engines if you can't get originals?
Well, we know where there are some. Our difficulty will be, and this is new old stock. I was amazed when I got into historic aviation just how much stock there is out there. Our difficulty will be getting the gentleman concerned to actually part with them and sell them to us. But we are talking, and we've had formal meetings with Rolls-Royce, who are happy to help us. But again, it all comes back to money. But we know where there's originals. Guy can refurbish them. We've just got to get hold of them. But if the worst came to the worst and unlimited funds, we could start from scratch.
Elliot G asks, will you be recreating all the elements of an original Mosquito so that it is as accurate and complete as possible, or will you be leaving out the bits that a recreational aircraft doesn't need, namely the systems, controls and fittings associated with weapons?
Yeah, it will not be an armed aircraft. We might be carrying dummy gun barrels for effect at air shows, but it will not have full armament. As I say, there will be some modern instruments, but yeah, we're not going to start World War III.
Colin J has some insight into the drawings from Broughton, and he mentioned from Airbus. He noted that these were the most complete and comprehensive set of drawings that are available, and the set that he used to operate and maintain RR299.
Oh, excellent. Please get in touch.
I'll note that one down.
Yeah. Oh, I remember the second part of an earlier question was about qualified pilots. There are already people that Bill Ramsey knows through his RAF connections getting in touch, asking us, can they be considered to fly? So through Bill's linkage, I don't think we'll be short of finding the right pilot or pilots.
Can you say something about modifications required to meet modern airworthiness requirements?
Right, we have to conform to BCAR CAP 553, chapter A3-7, which is about a 600-page document. My engineering colleagues read it every night. Basically, anything we do that deviates from the original has to be approved by the CAA, and there's a process, a procedure that has to be gone through to prove the safety of any modification. And that was, that's the same as when we were building a new Airbus. If we had a certified type and had to put a mod into it, we had to go through exactly the same process.
Once the aircraft is finished, this is from James Catmore, what will its approximate lifetime be?
Well, if we're only displaying for a few hundred hours during an airshow season every year, and provided we keep the aircraft in the right conditions and have the right maintenance regime, it's not unreasonable to say it could fly for 20 years. Because it's essentially a new aeroplane that will have very little use, and the limitations on operating it under the permit to fly will mean it won't see extreme conditions. So it'll be, as I say, 20 years is a conservative estimate.
Okay, I think given that we're creating more open questions now than we have already answered, I can sense that there has to be a time that we call it, and what we will try to do is to list all the questions and provide these to David. And if David's interested in responding in a different way, perhaps in written form, then these would be available on our website. But perhaps Neil Codgel says it all. He says, simply a thank you for such a superb, passionate presentation. You will be getting my pocket money as a donation shortly, and it will be great to see it fly. And as things progress, it'd be great to see you offering tours showing build progress. So perhaps you could comment on that.
I'd just like to say thank you. We're not called the People's Mosquito because we're a sort of a political organisation. It's because it's the people who are donating and helping who are going to help us make this fly. Thank you.
And Brian Preston loves your shirt, so can he get one? Can he buy one from you?
We do have a range of shirts available through our website, but this is a special director's shirt. So you can't have this type, but you can have something very similar through the website.
Wonderful. And over to...
But if you can have it for 8 million, how about that?
Over to Ian.
Thank you, George, and thank you, David, for that excellent both the presentation and Q&A session. So thank you both for doing that. I'd just like to finish off by saying, David, what a fascinating and absolutely brilliant presentation. I know you were slightly worried when we talked about doing it to this audience, but I thought personally it came across absolutely great. So well done, and thank you again from the IET Anglian Coastal Branch. As I said at the beginning, we have recording it and we are recording it. So it will be put onto our Anglian Coastal Local Network site. It will probably take us about a couple of weeks to get it on there because we like to pass it back to David before just putting it on there, but it will be made available. And I'd just like to also point, despite having a football match on, there's still 232 people listening to us. So I think that is just testament to how interesting people find these kind of subjects. So great, and thank you very much. So I'd just like to finish off by giving my formal thanks to David and for Tim, who originally put us in contact with you, David, for doing that. And just say thank you on behalf of all of us. We are busily working on the next set of presentations, and one of the things that I'd like to ask in our feedback form that we send out to everybody is whether you would like a follow-up from David, because I'm sure that, as he said, he's cut this presentation down to less than an hour, and he could talk a lot more. So if you're interested in a follow-up, perhaps you'd either let us or David know himself, and I'm sure we can set something up in the future. But for the next ones, please keep an eye out on our community's website, and we're busily planning the next ones that we've got to do. So finally, everybody who's joined the call, thank you for attending tonight. Thank you to George and others that have put on tonight's webinars, and that concludes this presentation for this evening. So thank you very much, and let's hope England are doing the business on the TV.